Hello there, and welcome to the Sleepy Science Place. I'm so glad you found your way here tonight. Maybe you've had one of those days where your mind kept spinning long after the world around you stopped. Or maybe you're simply the kind of person who prefers drifting off to the gentle hum of cosmic mysteries rather than staring at the ceiling in silence. Either way, you're exactly where you need to be. Tonight, we're going somewhere far beyond the edges of your bedroom, beyond the reach of tomorrow's worries and yesterday's regrets. We're heading out into the vast, velvety darkness of space, a place so enormous and so ancient that just thinking about it has a way of making our everyday concerns feel beautifully, peacefully small. Out there, among the stars and nebulas and silent planets, time moves differently. Distances stretch beyond comprehension. And in that infinite quiet, there's a strange kind of comfort waiting for you. Before we begin this journey together, I just want to invite you to get as comfortable as possible. Adjust your pillows, let your shoulders drop away from your ears, and allow your breath to find its own natural rhythm. There's no test at the end of this, no need to remember every detail. Some of these facts might wash over you like waves, and that's perfectly okay. You're not here to study, you're here to rest, to wonder, and maybe to dream. If you're new to this channel, welcome. And if you've been here before, welcome back. Either way, consider hitting that subscribe button and turning on notifications so you can drift off with us whenever you need a little cosmic comfort. A gentle like on this video helps it find other restless minds who might need a peaceful place to land tonight. But no pressure. Your only job right now is to relax. So let's begin. Let's take this slow journey together through the most soothing corners of the universe, where stars are born in silence, where light takes lifetimes to travel, and where every fact is a soft invitation to let go just a little bit more. Close your eyes whenever you're ready. There's no rush. The universe has been waiting billions of years. It can wait for you too. Out in the depths of space, there exists a cloud of alcohol floating through the cosmos, and it's so vast that if you could somehow gather it all together, you'd have enough to fill about 400 trillion pints. This cloud, located in a region called Sagittarius B2, is made mostly of methanol, and it drifts through the darkness near the center of our Milky Way galaxy like a cosmic vineyard nobody will ever visit. Scientists discovered it using radio telescopes, listening to the specific frequencies that molecules emit when they tumble through the cold vacuum. Imagine that, an ocean of alcohol suspended in starlight, silent and still. A reminder that the universe creates the most unexpected things in the quietest corners of forever. You don't need to understand the chemistry. You just need to know that out there in the dark, the cosmos is stranger and more wondrous than any dream. And while we're talking about strange wonders, let's consider the silence of space itself. In the movies, spaceships roar past the camera and explosions thunder across the screen, but the truth is far more peaceful. Space is a near-perfect vacuum, which means there's almost nothing there to carry sound waves. No air, no medium, no vibration traveling from one molecule to the next. If you could float outside a spacecraft and watch a star explode in the distance, you'd see a brilliant flash of light painting the darkness in gold and crimson and violet. But you'd hear absolutely nothing. Just your own heartbeat. Just your own breath inside your helmet. The universe conducts its most dramatic events in total, reverent silence, like a film projected without a soundtrack. And maybe that's why space feels so calming to think about at night. It's the ultimate quiet place, where even the loudest events unfold in a hush. Our moon, that faithful companion hanging in the sky above us, is slowly drifting away from Earth. Every year, it moves about 1.5 inches farther into the dark. It's been doing this for billions of years, ever since it first formed from the debris of an ancient collision, and it will keep drifting for billions more. The pull of tides, the dance of gravity, it all adds up, and the moon inches outward, patient and unstoppable. Right now, it's far enough that it takes about 1.25 seconds for light to travel from the moon to your eyes. But one day, in the unimaginably distant future, it will be so far that total solar eclipses won't happen anymore. The moon will appear too small in the sky to cover the sun completely. For now, though, it's still close enough to light your way home on a clear night, still close enough to pull the oceans into rhythm. And as you lie here tonight, it's up there, glowing softly, drifting just a little farther away. Did you know that the sunset you see on Earth would look entirely different on Mars? On our world, sunsets paint the sky in shades of orange and pink and deep red, the atmosphere scattering the shorter wavelengths of light and letting the warm colors flood through. But on Mars, where the atmosphere is thin and filled with fine dust particles, the opposite happens. The sky during the day glows a butterscotch orange, but as the sun dips below the horizon, the area right around it turns a soft, cool blue. Imagine standing on a quiet Martian plain, the red sand stretching endlessly in every direction, and watching that small, distant sun sink into a blue twilight. It's the kind of sight that would make you feel both impossibly far from home and strangely, beautifully at peace. Another world, another sunset, another shade of calm waiting at the edge of the day. Let's talk about time for a moment. Not the time on your clock, but the kind of time that only exists in the presence of gravity. Thanks to Einstein's theory of relativity, we know that time doesn't pass at the same rate everywhere. The stronger the gravitational field, the slower time moves. This means that if you were standing at the base of a mountain and your friend was standing at the summit, your friend would age ever so slightly faster than you. Just fractions of a second over a lifetime, but faster nonetheless. Astronauts aboard the International Space Station, orbiting high above the Earth where gravity is a little weaker, age just a tiny bit faster than those of us down here on the ground. It's as if the universe has built a gentle flexibility into the fabric of reality, a softness that lets time stretch and compress depending on where you are. You don't need to worry about it. Time is still time. But out there, in the vast choreography of gravity and motion, even seconds learn to bend. There's a place in space where diamonds rain from the sky. On planets like Neptune and Uranus, deep within their atmospheres, the crushing pressure and searing heat can transform methane into carbon, which then crystallizes into diamonds. These gems, some possibly as large as your hand, fall slowly through layers of hydrogen and helium, glittering in the dark, tumbling through storms that have raged for centuries. Eventually, they may sink so deep that they melt again, dissolving back into the planet's core. But for a time they fall like snow, silent, brilliant, unreachable. It's one of those facts that feels more like poetry than science, a reminder that the universe doesn't just create rocks and gas and empty space. It creates beauty, even where no one will ever see it. And tonight, as you rest here, somewhere far away, diamonds are falling through an alien sky, and no one is there to catch them, except maybe in your dreams. The center of our galaxy is home to a supermassive black hole called Sagittarius A, and it's so heavy that it weighs about 4 million times as much as our sun. This enormous void sits at the heart of the Milky Way, pulling stars into orbit around it like dancers circling a stage. Light itself can't escape once it crosses the black hole's event horizon, which means the very center of the galaxy is a place of absolute darkness, a gravitational well so deep that space and time curve into something we can barely imagine. And yet, for all its power, Sagittarius A is relatively quiet right now. It doesn't blaze with light or roar across the cosmos. It simply exists, patient and still, holding our galaxy together with invisible threads of gravity. There's something oddly soothing about that. This cosmic anchor, silent and steady, keeping hundreds of billions of stars in their slow, spiraling dance. Speaking of stars, did you know that the light from some of them has been traveling for so long that the stars themselves may no longer exist? When you look up at the night sky, you're not seeing the universe as it is right now. You're seeing it as it was. The light from the nearest star beyond our sun takes about 4 years to reach us. Light from more distant stars takes hundreds, thousands, even millions of years. This means that some of the pinpricks of light you see twinkling overhead on a clear night are echoes of stars that burned out long before humans ever walked the earth. You're looking at ghosts, in a way, beautiful luminous ghosts whose light has crossed unimaginable distances just to reach your eyes tonight. And in that light, in that long journey across the dark, there's a kind of tenderness. The universe is saying, I was here, I shone, and now you know. If you could somehow stand on the surface of Venus, you'd experience one of the strangest days in the solar system. A single day on Venus, one full rotation of the planet, takes about 243 Earth days. But a year on Venus, one complete orbit around the Sun, takes only about 225 Earth days. This means that a day on Venus is actually longer than a year. Time, in other words, moves in strange and unexpected ways depending on where you are. And if that weren't enough, Venus rotates in the opposite direction from most other planets, so the sun rises in the west and sets in the east. It's a topsy-turvy world wrapped in thick clouds of sulfuric acid, spinning slowly backward through space. You wouldn't want to visit. But from here, from the comfort and safety of your bed, it's fascinating to imagine a world where the rules are different, where time bends in unfamiliar ways, where even the sun doesn't know which way to go. There's a theory that the universe is not only expanding, but that the expansion is speeding up. This idea comes from observations of distant supernovae, and something scientists call dark energy, a mysterious force that seems to be pushing galaxies apart faster and faster as time goes on. No one really knows what dark energy is. It doesn't emit light, it doesn't interact with matter in any way we can detect, and yet it makes up about 68% of everything that exists. It's the universe's greatest mystery, and it's written in invisible ink across the cosmos. What this means in practical terms is that billions of years from now, galaxies will be so far apart that beings living in one galaxy won't be able to see any others. The night sky will be empty except for their own stars. They'll look out into the darkness and think they're alone. But right now, tonight, we can still see other galaxies. We can still look up and know we're part of something vast and interconnected. So take comfort in that. You're here at a good time. Let's drift for a moment to Saturn, that magnificent ringed giant floating in the outer reaches of our solar system. Those rings, so thin and delicate that if you could shrink them down to the size of a sheet of paper they'd be thinner than tissue, are made mostly of ice, chunks of frozen water ranging from the size of grains of sand to the size of mountains, all orbiting the planet in a glittering, shimmering disk. Scientists aren't entirely sure how old the rings are. They might be ancient, left over from the birth of the solar system, or they might be relatively young, formed when a moon wandered too close and was torn apart by Saturn's gravity. Either way, they're temporary. In another 100 million years or so, they'll likely be gone, pulled into the planet by gravity or scattered into space. But tonight, they're still there, catching the sunlight, glowing softly against the black. Another fleeting wonder in a universe full of them. And here's something that might make you feel both very small and very significant at the same time. Every atom in your body was once part of a star. The carbon in your cells, the oxygen you breathe, the calcium in your bones, the iron in your blood, all of it was forged in the nuclear furnaces at the hearts of ancient stars that lived and died long before the Earth existed. When those stars exhausted their fuel and exploded in supernovae, they scattered their elements across the galaxy, seeding the clouds of gas and dust that would eventually collapse to form new stars, new planets, and eventually, you are made of stardust, literally. The universe didn't just create you, it became you. Every breath you take, every heartbeat, every thought drifting through your mind right now is the cosmos experiencing itself. And maybe that's the most soothing fact of all. You're not separate from the universe. You're part of it. You always have been. You're doing wonderfully. There's no need to hold on to anything too tightly. If some of these facts drift past you like clouds, that's exactly what they're supposed to do. You're not here to memorize or to impress anyone. You're here to rest, to let your mind wander through something bigger than today's worries. So if you haven't already, let your eyes close. Feel the weight of your body sinking gently into the surface beneath you. Notice your breath, how it comes and goes without effort, without thought. The universe is breathing through you. And right now, that's all you need to do. Just breathe, just rest, just let yourself be here. We'll continue in a moment, but there's no rush. Time, as we've learned, is flexible. And tonight, it's on your side. Out beyond the orbit of Neptune lies a region called the Kuiper Belt, a vast ring of icy bodies and dwarf planets that marks the edge of what we used to think of as the solar system. Pluto lives out here, along with thousands of other frozen worlds tumbling slowly through the dark. These objects are leftovers from the formation of the planets, ancient fragments that never quite came together into something larger. They orbit the sun in near silence, untouched by sunlight strong enough to melt them, preserved in a deep freeze that has lasted for billions of years. It's a quiet neighborhood, a place where the sun is just another bright star in the sky, where the pace of life, if you can call it life, is measured in centuries and millennia. And there's something deeply peaceful about knowing it's out there. This cold frontier at the edge of our cosmic home, patient and still, waiting for the rare visitor who might one day pass through and wonder at its icy beauty. If you've ever looked up at the Milky Way on a clear, dark night, you've seen the combined light of billions of stars blending together into a soft, glowing river across the sky. But here's the thing. Our galaxy is just one of an estimated 2 trillion galaxies in the observable universe. 2 trillion. Each one containing billions or even trillions of stars. Each star potentially surrounded by planets. Each planet a world unto itself, with its own mountains and valleys, its own weather, its own silent sunrises. The scale of it is so overwhelming that it almost stops meaning anything. Numbers that large don't fit inside our everyday experience. And maybe that's okay. Maybe the point isn't to comprehend it all, but to simply let yourself feel the immensity, to let it wash over you like a wave, and to find comfort in the fact that we're part of something so impossibly, magnificently vast. You are here, on this one planet in this one moment, and that's enough. Let's talk about neutron stars for a moment, some of the densest objects in the universe. When a massive star exhausts its nuclear fuel and collapses, the core can be compressed into a sphere only about 12 miles across, but with a mass greater than the Sun's. A single teaspoon of neutron star material would weigh about 1 billion tons. Gravity on the surface is so strong that if you could somehow stand there, you'd be flattened instantly into a layer of atoms just 1 atom thick. And some neutron stars spin. Fast, really fast. The fastest ones, called pulsars, can rotate hundreds of times per second, sweeping beams of radiation across space like cosmic lighthouses. From our perspective, they pulse with metronomic precision, some keeping time more accurately than the best atomic clocks we've ever built. It's a strange thought. These impossibly dense, wildly spinning remnants of dead stars, out there in the dark, ticking away the seconds with perfect, relentless rhythm. Time once again taking on a new shape depending on where you are. There's a phenomenon called the overview effect, experienced by astronauts who have had the chance to see Earth from space. When they look back at our planet, this blue marble suspended in the blackness, wrapped in swirls of white clouds, the continents and oceans all visible at once, something shifts inside them. Borders disappear. Conflicts seem small. The fragility and beauty of our world become overwhelmingly clear. They describe feeling a profound sense of connection, not just to other people, but to the planet itself, to the thin layer of atmosphere that keeps us all alive, to the delicate balance that allows life to flourish here. Many of them say it changed them forever. And while most of us will never see Earth from that perspective, maybe we can borrow a little of that feeling tonight. Maybe we can imagine, just for a moment, what it would be like to float in silence above the world, to see how small our troubles are and how vast the beauty is, and to carry that sense of peace back down with us into sleep. Did you know that space smells like something? Astronauts who have come back inside after spacewalks report a distinct odor clinging to their suits, a smell they describe as metallic, like seared steak or welding fumes, with a hint of something sweet, like burnt almonds or rum. Scientists think this smell comes from polycyclic aromatic hydrocarbons, complex molecules that form in the dying embers of stars and drift through space until they stick to spacesuits during extravehicular activities. So in a way, when astronauts smell space, they're smelling stardust, the leftover chemistry of stellar explosions, the molecular ghosts of ancient suns. It's such a human thing, isn't it, to notice the smell of the cosmos. We reach out into the infinite and bring back sensory memories, tiny details that make the universe feel just a little more real, a little more touchable. And tonight, even though you're here in bed, you can imagine it, that strange, sharp, almost comforting scent of the stars. One of the most beautiful sights in our solar system is also one of the most fleeting. On Jupiter, auroras dance across the polar skies just like they do on Earth. But these are auroras on a scale we can barely imagine. They're hundreds of times more powerful than ours, fueled by Jupiter's intense magnetic field and the volcanic moon Io, which spews charged particles into space that get caught in the planet's magnetosphere. The result is a shimmering curtain of light, glowing in ultraviolet and infrared, flickering and swirling above the clouds of the largest planet in our solar system. No human has ever seen them up close. Maybe no human ever will. But spacecraft have captured glimpses, and those glimpses reveal something astonishing. That even on a world made mostly of gas, a world with storms the size of Earth that have raged for centuries, there is beauty. There is light. There is wonder waiting in the dark. Let's drift outward now, past the Kuiper Belt, past the scattered disk of distant ice, into a region of space called the Oort cloud. This is a vast, spherical shell of icy debris that surrounds the entire solar system, stretching out almost a light year from the sun, nearly a quarter of the way to the nearest star. It's so far out that sunlight is little more than a memory, and the objects here take millions of years to complete a single orbit. The Oort cloud is thought to contain trillions of comets, frozen and dormant, waiting for some distant gravitational nudge to send them tumbling inward toward the warmth of the sun. Occasionally, one of them makes that journey, crossing the vast gulf of space to become a bright visitor in our skies, a streak of ice and dust catching the sunlight as it swings around the sun and heads back into the dark. And then it's gone again, disappearing into the Oort cloud's patient, silent embrace. It's the edge of our solar system, the last frontier before the interstellar night begins. And out there in that cold, quiet boundary, time almost stands still. Here's something that might surprise you. The planet Mercury, the closest planet to the Sun, is not the hottest planet in the solar system. That title belongs to Venus, whose thick atmosphere of carbon dioxide traps heat so effectively that surface temperatures soar to about 900 degrees Fahrenheit, hot enough to melt lead. Mercury, by contrast, has almost no atmosphere to hold in the heat, so while its sunny side can reach over 800 degrees, its night side plummets to nearly 300 degrees below zero. It's a world of extremes, baking and freezing in turns as it spins slowly under the sun's relentless gaze. But Venus, wrapped in clouds and greenhouse gases, stays scorching hot all the time, day and night, everywhere across its surface. It's a reminder that proximity isn't everything. Sometimes it's the blanket, not the distance, that makes all the difference. And tonight, as you rest beneath your own blankets, maybe you can appreciate the perfect balance we have here on Earth. Not too hot, not too cold, just right for dreaming. There's a spacecraft out there, right now, traveling farther from Earth than any human-made object has ever gone. Voyager 1, launched in 1977, has left the solar system behind and is now moving through interstellar space, the vast emptiness between the stars. It's about 14 billion miles away, so distant that signals from Earth take more than 22 hours to reach it. And yet, it's still sending data back, still whispering across the void, telling us what the universe looks like from out there in the dark. Voyager carries a golden record, a message intended for any intelligent life that might one day find it. A collection of sounds and images from Earth, music and greetings in dozens of languages, a snapshot of who we are and what we love. It's a bottle cast into the cosmic ocean, drifting farther every second, carrying a piece of us into the forever. And even if no one ever finds it, the gesture itself is beautiful. We reached out. We said, we were here. We wondered. We cared. Let's talk about the moon for a moment, but not our moon. Europa, one of Jupiter's many satellites. Beneath Europa's icy crust lies an ocean of liquid water, possibly twice the volume of all of Earth's oceans combined. It's kept warm by tidal heating, the gravitational squeeze and stretch of Jupiter, and the other moons kneading Europa's interior like dough, generating friction and heat. Scientists believe this subsurface ocean could have the right conditions for life: liquid water, energy, and organic molecules. We don't know if anything lives there. We may not know for decades, but the possibility is tantalizing. Somewhere beneath that cracked, frozen surface in the absolute darkness of an alien sea, there might be something stirring, something alive, something that has never seen the sun. And whether it's there or not, the idea alone is enough to make you feel a little less alone in the universe. We're looking, we're wondering, and maybe somewhere something is wondering back. Here's a fact to ponder as your thoughts begin to drift. The universe is mostly empty. The distances between stars, between galaxies, between the tiny particles that make up matter itself, they're almost incomprehensibly vast. If you could shrink the solar system down so that the sun was the size of a basketball, Earth would be a tiny bead about 26 yards away, and the nearest star would be more than 4,000 miles distant. Most of space is just that: space, emptiness, silence. And yet in that emptiness, in those vast gulfs of nothing, there's a strange kind of fullness. There's potential. There's room for light to travel, for gravity to work its slow magic, for galaxies to wheel through the dark without bumping into each other. The emptiness is not a flaw. It's part of the design. It's what makes the universe possible. And tonight, as you lie here in the quiet of your room, maybe you can appreciate your own empty spaces, the pauses between breaths, the moments between thoughts, the stillness that makes rest possible. And speaking of rest, let's consider the fate of stars themselves. Most stars, including our sun, will eventually exhaust their nuclear fuel and gently collapse into white dwarfs, dense, cooling embers about the size of Earth, slowly radiating away their remaining heat over billions upon billions of years. They'll fade gradually, dimming from white to yellow to red to a faint, barely perceptible glow, until finally they become black dwarfs, cold, dark spheres of crystallized carbon and oxygen, floating silently through space, their fusion fires long extinguished. The universe isn't old enough yet for any black dwarfs to exist, but one day in the unimaginably distant future, the cosmos will be filled with them, quiet monuments to stars that once burned bright. It's a peaceful ending in its way. No explosion, no drama, just a slow, gentle cooling, a return to stillness. And maybe, when our own sun reaches that stage billions of years from now, It will dream in whatever way a dying star can dream of the worlds it warmed and the life it made possible, including you, including this moment. Let's pause here for a breath. You've traveled so far already, through clouds of alcohol and fields of diamonds, past black holes and neutron stars, out to the edge of the solar system and beyond. And you've done it all without leaving the comfort of your bed. That's the magic of the mind, isn't it? The ability to wander anywhere, to imagine anything, to find peace in the vastness of the cosmos even while your body rests here, safe and warm. So take a moment now. Feel the gentle rise and fall of your chest. Let your jaw relax, let your hands soften. There's nowhere you need to be, nothing you need to do. The universe will continue its slow, patient dance whether you're paying attention or not. And that's okay. You can let go now. We'll keep going in just a moment, but for now, just rest. There's a place in space where scientists have detected the largest known reservoir of water in the universe. It's a quasar, an intensely bright, distant object powered by a supermassive black hole, located about 12 billion light-years away. Surrounding this quasar is a cloud of water vapor containing about 140 trillion times the amount of water in all of Earth's oceans combined. It's spread out over hundreds of light-years, suspended in space like an impossibly diffuse mist, each molecule tumbling through the dark, warmed ever so slightly by the radiation from the quasar's blazing core. The water isn't liquid, of course. It's vapor, existing in conditions that would be lethal to any life we know. But it's water nonetheless, that same simple molecule that fills our oceans and rivers, that quenches our thirst and makes life possible. And finding it out there, in such unimaginable quantities, reminds us that the building blocks of life are everywhere. The universe is not just vast and empty, it's wet. Let's turn our attention now to the concept of light years, because it's one of those measurements that sounds almost poetic. A light year is the distance light travels in 1 year, moving at about 186,000 miles per second. That works out to roughly 6 trillion miles. When we say a star is 10 light years away, we mean that the light we see from it tonight left that star 10 years ago. The farther we look into space, the farther back in time we're seeing. The most distant galaxies we've observed are so far away that their light has been traveling for more than 13 billion years, meaning we're seeing them as they were when the universe was still young, still forming its first stars and galaxies. In a very real sense, telescopes are time machines. They let us look into the past, to witness events that happened long before our planet even existed. And there's something deeply moving about that. The idea that light, patient and persistent, carries the story of the universe across unimaginable distances just so we can see it and wonder. Here's a gentle thought to accompany you into deeper rest. The universe has no center. Or, to put it another way, everywhere is the center. When the Big Bang occurred about 13.8 billion years ago, it didn't explode outward from a single point in pre-existing space. Instead, space itself began expanding everywhere at once. Every point in the universe is moving away from every other point, like dots on the surface of an inflating balloon. This means that no matter where you are in the cosmos, it will look like everything else is moving away from you, as if you were at the center of the expansion. And in a way, you are. We all are. Every galaxy, every star, Every tiny mote of dust drifting through the void is at the center of its own observable universe. You are not on the edge of things looking in. You are right here at the heart of everything, just as central to the story as any distant quasar or spiral galaxy. The universe is unfolding around you. And tonight, that thought can be a kind of comfort. A reminder that you matter, that you belong, that you are exactly where you're supposed to be. Did you know that the sun loses about 4 million tons of mass every second? It's converting that mass into energy through nuclear fusion, turning hydrogen into helium in its core, and releasing a flood of light and heat in the process. That energy radiates outward, taking about 170,000 years to work its way from the core to the surface, and then just 8 minutes to cross the void and warm your face on a sunny afternoon. The sun has been doing this for about 4.5 billion years, and it will keep doing it for another 5 billion or so before it runs out of hydrogen and begins to change. But even losing 4 million tons every second, the sun is so massive that this process barely makes a dent. It's a reminder of the sheer scale of stellar engines, the unimaginable power required to light up a solar system, to make life possible on a small blue planet orbiting in the habitable zone. And it does all of this without effort, without thought, simply because that's what stars do. They burn, they shine, they give. And tonight, even though the sun has set wherever you are, it's still out there, still burning, still waiting to rise again. Let's talk about the great red spot on Jupiter, a storm so large that Earth could fit inside it twice over, with room to spare. This anticyclonic tempest has been raging for at least 350 years, possibly much longer, and it shows no signs of stopping. Winds inside the storm reach speeds of up to 400 miles per hour, swirling in a vast oval of churning clouds, driven by forces we're only beginning to understand. The storm is slowly shrinking, though, becoming a little smaller each year, and scientists aren't sure why. Maybe one day it will disappear entirely, fading into Jupiter's banded atmosphere like a dream dissolving at dawn. But for now, it endures, a testament to the raw, untamed power of gas giants, a reminder that planets don't just sit there quietly in space. They breathe, they storm, they change. And even on worlds where no one will ever stand, beauty and chaos dance together in the clouds. And here's one more thought before we move on. The stars you see in the night sky are not scattered randomly. They're part of constellations, patterns that humans have been recognizing and naming for thousands of years. But those patterns are accidents of perspective. The stars in any given constellation are usually nowhere near each other in space. One might be dozens of light years away, another hundreds. They just happen to line up from our point of view here on Earth, creating shapes that our ancestors saw as hunters and animals and gods. In a few million years, as stars move through the galaxy, those patterns will change. The Big Dipper will look like something else. Orion will lose his belt. New patterns will emerge, and future beings, if there are any, will tell different stories about the sky. But tonight, right now, the stars are exactly where they've been for your entire life, hanging overhead in familiar shapes, silent witnesses to every moment you've ever lived. And there's a comfort in that continuity, in knowing that some things remain, even as everything else changes. Out in the constellation of Cygnus, there's a star called KIC 8,462,852, though most people know it as Tabby's star. A few years ago, astronomers noticed something strange. The star's brightness was dimming in irregular patterns, sometimes dropping by as much as 22%, far more than would be caused by a planet passing in front of it. Theories ranged from swarms of comets to clouds of dust, but for a while, some people wondered if it might be something more exotic, perhaps a massive alien megastructure, like a Dyson swarm, built by an advanced civilization to harvest the star's energy. More recent observations suggest the dimming is probably caused by dust, not aliens, but the mystery captivated imaginations around the world. And maybe that's the real story here. Not whether alien megastructures exist, but the fact that we're looking, that we're curious enough to wonder, that we're scanning the skies not just for rocks and gas, but for signs of other minds reaching back. The universe might be full of wonders we haven't imagined yet, and every strange flicker of light is an invitation to keep looking, keep wondering, keep dreaming. Let's talk about time dilation again, but from a different angle. If you could travel at speeds close to the speed of light, time would slow down for you relative to people back on Earth. This isn't science fiction. It's a direct consequence of Einstein's theory of relativity, and it's been confirmed in countless experiments. If you boarded a spacecraft and accelerated to, say, 99% the speed of light, and traveled out into space for what felt like 5 years to you, when you returned to Earth you might find that 50 years had passed here. Your friends would be older, the world would have changed, and you'd have experienced a kind of time travel into the future. It's a strange and slightly melancholy thought, this disconnect between time as you experience it and time as it flows for everyone else. But it also means that the universe is not as rigid as it seems. Time, space, motion, they're all woven together in a flexible fabric that bends and stretches depending on how fast you're moving and how strong the gravity is around you. And tonight, as you rest here at relatively slow speeds in a relatively weak gravitational field, time flows steadily and gently, carrying you second by second toward morning. Did you know that the color of a star tells you its temperature? The coolest stars glow red, their surfaces simmering at a few thousand degrees. Hotter stars shine orange or yellow like our sun. Hotter still, and they burn white. The very hottest stars blaze blue, their surfaces reaching tens of thousands of degrees, pouring out ultraviolet light in waves. When you look up at the night sky and see stars twinkling in different colors, you're not just seeing lights, you're seeing thermometers, cosmic beacons revealing the fundamental physics of distant suns. Red giants nearing the ends of their lives, blue supergiants burning through their fuel at breakneck speeds, yellow dwarfs like our sun settled into a steady middle age. Each color is a story. Each star is a world unto itself, burning in its own unique way, contributing its own thread to the vast, glowing tapestry of the galaxy. And from here, from your small, warm room, you can look up and read the temperature of the cosmos written in colored light. There's a concept in astronomy called the habitable zone, sometimes called the Goldilocks zone, the region around a star where conditions are just right for liquid water to exist on a planet's surface. Too close to the star and water boils away. Too far and it freezes solid. But in that narrow band, in that sweet spot of orbital distance, water can flow, and where water flows, life as we know it has a chance. Earth sits comfortably in the sun's habitable zone, and scientists have now identified thousands of exoplanets, planets orbiting other stars, many of which also fall within their star's habitable zone. We don't know yet if any of them harbor life. We may not know for a long time. But the fact that there are so many possibilities, so many worlds where the conditions might be right, is profoundly hopeful. We are probably not alone. And even if we are, even if life is vanishingly rare, we're here in our own Goldilocks zone, breathing and dreaming under a sun that shines with exactly the right warmth. And tonight, that's more than enough. Let's drift to Mars for a moment, to a feature called Olympus Mons, the largest volcano in the solar system. It's a shield volcano, similar in structure to the volcanoes in Hawaii, but on a scale that beggars belief. Olympus Mons stands about 13.5 miles high, nearly 3 times the height of Mount Everest, and its base is roughly the size of the state of Arizona. If you could stand at the center of its summit caldera and look around, the horizon would be so far away that the slope of the volcano would be almost imperceptible. You'd feel like you were standing on a flat plain, not realizing you were on top of the tallest mountain in the solar system. It's a humbling thought, this volcano that dwarfs anything on Earth, built over millions of years by lava flowing quietly across the Martian surface. No one has ever climbed it. No one has ever seen it up close. But spacecraft have mapped it in exquisite detail, and in those maps, we can trace the history of a world that was once far more geologically active than it is now. Mars remembers. And in its mountains and valleys, its dry riverbeds and ancient volcanoes, it tells the story of what it used to be. Here's something gentle to carry with you as you sink deeper into rest. The Voyager spacecraft, which we talked about earlier, carries sounds of Earth into the cosmos. Waves crashing on a beach, wind rustling through trees, the songs of whales and birds, laughter, music, a mother's kiss. These sounds are encoded on the golden record, waiting for the day when someone or something might play them back and hear what our world sounds like. It's unlikely that day will ever come. The odds of Voyager encountering another civilization are astronomically small, and even if it does, it will be millions or billions of years from now. But the gesture itself is what matters. We sent a message into the universe that says, this is who we are. This is what we love. This is the sound of our home. And in doing so, we reminded ourselves of what's worth preserving, worth celebrating, worth carrying forward. The sound of waves, the laughter of children, the music we make when we're happy. These are the things that matter. These are the things we wanted the universe to know about us. And tonight, you can close your eyes and hear them in your memory. The gentle, beautiful sounds of Earth. You're doing so well. If your mind has started to wander, if you've drifted in and out of these facts like waves lapping at the shore, that's exactly right. You don't need to hold on to any of this. You don't need to remember the names of stars or the distances to galaxies. All you need to do is let the rhythm of the words carry you. Let the ideas wash over you like a gentle tide. Notice how your breathing has slowed, how your body feels heavier, more at ease. The universe is vast, but you are right here, right now, and that's all that matters. There's no test, no deadline, no urgency. Just the slow, patient unfolding of facts and wonder and the quiet space between them where sleep is waiting. Rest now. We'll continue soon. There's a type of star called a magnetar, a neutron star with a magnetic field so powerful that it defies comprehension. The magnetic field of a magnetar can be 1,000 trillion times stronger than Earth's, strong enough that if one were located halfway between here and the moon, it would erase the magnetic strips on every credit card on Earth and pull the iron from your blood. Magnetars occasionally release bursts of energy called starquakes, where the star's crust cracks and releases a flood of gamma rays and X-rays into space. These events, lasting only a fraction of a second, release more energy than the sun produces in a year. And yet, even these violent, unimaginably powerful objects are just part of the universe's natural tapestry, just another way matter and energy arrange themselves in the aftermath of stellar death. They're rare, distant, and utterly inhospitable, but they're also beautiful in their extremity, a reminder that the cosmos operates on scales and intensities we can barely imagine, and that our own experience is just one tiny, gentle corner of a much wilder reality. Let's talk about cosmic microwave background radiation, the faint afterglow of the Big Bang itself. About 380,000 years after the universe began, it cooled enough for atoms to form, and light was finally able to travel freely through space. That light has been traveling ever since, stretched and cooled by the expansion of the universe, until now it exists as a faint microwave hum, filling every corner of the cosmos. Telescopes can detect this radiation, and by studying its tiny fluctuations, scientists have been able to map the structure of the early universe, to see the seeds of galaxies and clusters of galaxies that would form billions of years later. It's a kind of cosmic baby picture, a snapshot of the universe when it was just beginning. And the fact that we can see it, that we can look back across 13.8 billion years and glimpse the moment when everything started, is nothing short of miraculous. We are looking at our own origin story, written in light that has traveled across the entire history of the universe just to reach us tonight. Here's a fact that might make you smile. In space, tears don't fall. Astronauts have discovered that if you cry in microgravity, the tears just pool up in your eyes, forming little liquid spheres that cling to your face until you wipe them away. It's such a small, human detail in the midst of all this cosmic grandeur, a reminder that even in the most extraordinary environments, we're still ourselves, still subject to the tiny quirks and vulnerabilities that make us human. Emotions don't stop working just because gravity does. Sadness, joy, wonder, they all travel with us wherever we go, whether we're on Earth or floating in the cupola of the International Space Station, looking down at the planet below. And maybe that's comforting in a way. No matter how far we go, no matter how strange the universe becomes, we bring ourselves along. We bring our feelings, our memories, our capacity to be moved by beauty. And that's worth something. That's worth everything. Let's turn our gaze now to the Andromeda Galaxy, our nearest large galactic neighbor, floating about 2.5 million light-years away in the night sky. Andromeda is similar to the Milky Way in size and structure, a vast spiral of stars and gas and dust, home to perhaps 1 trillion suns, each one a potential anchor for planets and moons and maybe even life. On a clear, dark night, if you know where to look, you can see Andromeda with the naked eye. It appears as a faint, elongated smudge of light, and what you're seeing is the combined glow of billions of stars, photons that left Andromeda 2.5 million years ago, long before humans evolved, and have been traveling through the void ever since just to reach your eyes tonight. And here's the astonishing part. Andromeda is moving toward us. The Milky Way and Andromeda are on a collision course, drawn together by gravity, and in about 4 billion years they will merge, their stars mingling in a slow, graceful dance that will take millions of years to complete. No stars will actually collide, space is too vast, but the two galaxies will become one. And by the time that happens, the Sun will be nearing the end of its life, and Earth, if it still exists, will be a very different place. But tonight, Andromeda is still separate, still distant, still a reminder that even galaxies are not static. They move, they interact, they change. And in the immensity of cosmic time, even the grandest structures are temporary. Did you know that there are stars older than the universe itself? Well, sort of. When scientists first started calculating the ages of the oldest stars in our galaxy, some of the results came out slightly older than the estimated age of the universe, a paradox that suggested something was wrong with our measurements or our models. Further refinement resolved the issue. The stars are indeed younger than the Big Bang, but only just. These ancient stars, some of them nearly as old as the cosmos, formed in the first few 100 million years after the universe began, back when the only elements available were hydrogen, helium, and tiny traces of lithium left over from the Big Bang. They're called population III stars, and none of them exist anymore. They've all long since burned out and exploded, seeding the universe with heavier elements that would later become planets and people. But their descendants are still out there, faint and red and impossibly old, slowly fading in the outer reaches of the galaxy. They're witnesses to almost the entire history of the universe, silent and patient, waiting for the end. And there's something poetic about that. These ancient lights flickering in the dark, carrying within them the memory of a younger, simpler cosmos. Here's a soothing thought to ease you further into rest. The Earth is always moving, and yet you don't feel it. We're spinning on our axis at about 1,000 miles per hour, orbiting the Sun at roughly 67,000 miles per hour. And the entire solar system is racing around the center of the galaxy at about 500,000 miles per hour. The galaxy itself is moving through space at over 1 million miles per hour relative to the cosmic microwave background. And yet, here you are, lying still, feeling perfectly at rest. The motion is so smooth, so constant, that it's invisible to your senses. You're hurtling through space at unimaginable speeds, and it feels like nothing at all. And maybe that's a metaphor for life itself. How much is happening beneath the surface? How much momentum and energy and change is occurring even in moments that feel still and quiet? You are never truly motionless. You're always traveling, always part of the great cosmic dance. And tonight, you can let that motion carry you gently into sleep, trusting that the universe knows where it's going, even if you don't. Out in the asteroid belt between Mars and Jupiter tumbles a small world called Ceres, the largest object in the belt, about the size of Texas, round enough to be classified as a dwarf planet. For a long time, Ceres was just a dot of light in telescopes, a curiosity catalogued and then largely forgotten. But in 2015, NASA's Dawn spacecraft arrived and began mapping its surface, revealing a world far stranger than anyone expected. Ceres has bright spots, patches of reflective material, probably ice or salt deposits, gleaming on its dark, cratered surface. It may have a subsurface ocean, kept liquid by heat from radioactive decay. It's a small world far from the sun, and yet it holds secrets, mysteries that hint at a complex geology we're only beginning to understand. And there's something touching about that, this little world, tucked away in the debris of the solar system's formation, quietly holding on to its stories, waiting for someone to notice. We noticed. We sent a spacecraft. And Ceres rewarded us with surprises. The universe, it turns out, is full of small wonders. Let's consider for a moment the loneliness of the cosmic void. The space between galaxies is almost perfectly empty. Just a few stray atoms per cubic meter, drifting through a darkness so complete that no human-made instrument could ever detect any light. If you could somehow stand in one of these intergalactic voids, far from any galaxy, far from any star, the sky would be utterly, perfectly black. No stars, no nebulae, no faint glow of distant galaxies. Just darkness in every direction forever. And yet, even there, you wouldn't be entirely alone. The cosmic microwave background would still surround you, that faint hum of radiation from the Big Bang, the ghost of the universe's beginning. And gravity would still be at work, however gently, tugging on you from distant clusters of galaxies, connecting you to the web of structure that spans the cosmos. Even in the emptiest places, you're part of something larger. Even in the darkest voids, the universe remembers you're there. Here's something that might help you relax even more. The universe is under no obligation to make sense to us. It's so much older, so much larger, and so much stranger than our everyday experience that we shouldn't expect it to conform to our intuitions. And that's okay. You don't need to understand quantum mechanics or general relativity or the intricacies of stellar nucleosynthesis to appreciate the beauty of a starry night. You don't need to know how many light years away a galaxy is to feel awe when you see its image. The universe is not a puzzle you need to solve. It's a mystery you're invited to wonder at. And tonight, as you lie here, you can let go of any need to comprehend it all. Just let it be vast. Just let it be strange. Just let it be beautiful. And let that beauty carry you, gently into sleep. Let's talk about pulsars again, but from a different angle. Some pulsars are so stable in their rotation that they rival the best atomic clocks on Earth. Astronomers use them as cosmic metronomes, timing their pulses with extraordinary precision to test theories of gravity, to detect gravitational waves, even to navigate spacecraft. There's something deeply reassuring about this. The idea that the universe, for all its chaos and randomness, also contains these perfect rhythms, these unshakable beats. Neutron stars spinning hundreds of times per second, ticking away with clockwork precision, reliable to within microseconds over years. It's as if the cosmos itself is keeping time, counting down the seconds and minutes and eons with tireless patience. And tonight, as you rest here, time is being kept for you. The universe is ticking along, steady and sure. and you don't have to do anything but be present for it. There's a place on Mars called Valles Marineris, a canyon system so enormous it makes the Grand Canyon look like a scratch in the dirt. Stretching about 2,500 miles long, up to 4 miles deep, and nearly 400 miles wide in places, Valles Marineris is a scar across the face of Mars, a wound left by geological processes that are still not fully understood. It might have formed from the cooling and cracking of the planet's crust, or perhaps from tectonic activity early in Mars's history. Either way, it's a breathtaking feature, a landscape of towering cliffs and deep, shadowed trenches, painted in shades of rust and ochre and deep brown. No one has ever walked along its rim or descended into its depths, but rovers and orbiters have sent back images, and those images reveal a world of stark alien beauty. Mars is not dead, it's resting. And in its canyons and craters and ancient riverbeds, it dreams of what it used to be. And here's one last thought before we move on to the next interlude. The universe is expanding, but not into anything. There's no outside the universe, no pre-existing space it's growing into. Instead, space itself is stretching, carrying galaxies along with it, like dots on the surface of an inflating balloon. This means that the farther away a galaxy is, the faster it appears to be moving away from us, not because it's traveling through space, but because the space between us and it is growing. And if you go far enough, there are galaxies so distant that the space between them and us is expanding faster than light can travel. We will never see those galaxies. Their light will never reach us. They exist beyond what's called the cosmological horizon, forever out of reach, forever invisible. And yet, they're still out there, still real, still full of stars and planets and perhaps even life. The universe is larger than the part we can see. And there's something both humbling and comforting in that. The knowledge that there are wonders beyond our horizon, places we'll never visit, stories we'll never hear, and that's okay. We have our own corner of the cosmos, and it's more than enough. How are you feeling? Hopefully you're starting to drift, your thoughts becoming softer, less distinct, blending together like watercolors on wet paper. If you're still awake, that's perfectly fine. There's no rush. If you've already dipped into sleep and come back, that's fine too. Let yourself float in that in-between space where you're not quite awake and not quite asleep, where the line between the two becomes beautifully blurred. The universe doesn't mind. It's been here for billions of years, and it will be here long after you wake, so rest. Let go. Let the stars and planets and galaxies spin on without you for a while. You've earned it. There's a moon in our solar system that has geysers, towering plumes of water vapor and ice that erupt from cracks in its frozen surface and shoot hundreds of miles into space. That moon is Enceladus, a small, bright satellite of Saturn, and the geysers are powered by a subsurface ocean kept warm by tidal heating, just like Europa. NASA's Cassini spacecraft flew through these plumes and analyzed their composition, finding not just water but also organic molecules and salts, ingredients that, on Earth at least, are associated with life. We don't know if Enceladus harbors life, but the possibility hangs there, tantalizing and just out of reach, in those icy jets spraying into the vacuum of space. Somewhere beneath Enceladus's frozen crust, in the dark, pressurized depths of an alien ocean, there might be hydrothermal vents, warm water, chemistry happening in the dark. And if life can exist there in that cold, remote place, then maybe it can exist almost anywhere. Maybe the universe is more full of life than we ever dared to imagine. Let's talk about the concept of deep time, the almost incomprehensible stretches of time that geology and astronomy deal with. 1,000,000 years is a long time by human standards, but in the history of the Earth, it's a blink. The planet is 4.5 billion years old. The universe is 13.8 billion years old. These numbers are so large they stop having meaning in any practical sense. But deep time teaches us perspective. It reminds us that the mountains we think of as eternal are temporary, that continents drift and oceans open and close, that species rise and fall, that even stars are born and die. And yet in the midst of all that change, here we are, alive in this particular moment, aware and conscious and capable of pondering our place in the story. It's miraculous, really. You are a brief, bright flicker in the immensity of deep time, but you are a flicker nonetheless. You're here, you matter. And tonight, in this fleeting moment, you can rest. Did you know that some exoplanets, planets orbiting other stars, are so strange they challenge everything we thought we knew about planetary formation? There are hot Jupiters, gas giants orbiting so close to their stars that their atmospheres are being stripped away by stellar wind. There are rogue planets, untethered to any star, wandering through interstellar space in total darkness. There are super-Earths, rocky worlds larger than our own, and mini Neptunes, ice giants smaller than anything in our solar system. There are planets with skies full of molten glass rain, planets where one side always faces the star and the other is locked in eternal night, planets orbiting binary stars with two suns in the sky. The diversity is staggering, and every new discovery expands our understanding of what a planet can be, what conditions might exist, where life might take hold. The universe is not just one story. It's an anthology of stories, each one unique, each one waiting to be read. Here's a fact to ponder as your breathing slows even more. The atoms in your body are mostly empty space. The nucleus of an atom is tiny compared to the electron cloud surrounding it. If you scaled an atom up so that the nucleus was the size of a marble, the electron cloud would extend out about 1/2 mile. And the electrons themselves are even smaller, more like probabilities than solid objects. What this means is that you and everything around you are mostly nothing. The solidity you feel, the weight and texture and presence of the physical world, is an illusion created by electromagnetic forces between atoms, not by the atoms themselves. You are a pattern, a structure, a dance of forces held together by invisible fields. And in a way, that makes you even more remarkable. You're not a thing, you're a process. You're a temporary arrangement of energy and matter, held together just long enough to think and feel and wonder about the stars. And when you finally dissolve back into the universe, your atoms will go on to become other things, other stars, other worlds, other beings. You are the universe, experiencing itself, over and over again. Let's drift back to Saturn one more time because it deserves it. This planet, with its magnificent rings and its family of moons, is one of the most beautiful objects in the solar system. Through even a small telescope, Saturn takes your breath away. Those rings tilted at an angle, glowing softly in the sunlight. The planet itself a serene, pale gold. But what you might not know is that Saturn's density is so low that if you could find a bathtub big enough, Saturn would float. It's made mostly of hydrogen and helium, the lightest elements, and despite its enormous size, it's less dense than water. It's a giant balloon of gas, held together by gravity, spinning slowly in the outer reaches of the solar system. And there's something endearing about that, this majestic ringed giant, so imposing and so beautiful, and yet so light it could float. The universe has a sense of whimsy, it seems. Even in the midst of all its grandeur, it makes room for lightness, for grace, for things that defy expectation. And here's one more gentle thought. Somewhere out there right now, a star is being born. Deep inside a nebula, a cloud of gas and dust is collapsing under its own gravity, growing denser and hotter at the center, until the pressure and temperature become so intense that hydrogen atoms begin to fuse into helium. And at that moment, a new star ignites, flooding the surrounding space with light and heat, pushing back the darkness, beginning a life that might last millions or billions of years. Stars are being born all the time, all across the galaxy, in nurseries hidden behind veils of dust and gas. We can't see most of them until they're already shining, but they're there, coming into being, adding their light to the cosmic tapestry. And in a poetic way, maybe you're like that too. Maybe every moment of awareness, every thought, every dream is a kind of birth, a small star lighting up in the darkness of the mind. And tonight, as you drift towards sleep, maybe you're not ending the day. Maybe you're just becoming a different kind of light. There's a phenomenon in space called gravitational lensing, where the gravity of a massive object, like a galaxy or a cluster of galaxies, bends the light from objects behind it, magnifying and distorting them like a cosmic lens. Einstein predicted this effect, and astronomers have used it to study some of the most distant galaxies in the universe, galaxies so far away and so faint that they'd be invisible without the help of a gravitational lens in the foreground. Sometimes the lensing creates multiple images of the same object, arcs of light stretched and smeared across the sky. Sometimes it creates Einstein rings, perfect circles of light surrounding the lensing mass. It's a beautiful reminder that even light, the fastest thing in the universe, bends to the will of gravity. Space is curved. Time is flexible. And the universe uses its own mass to show us wonders we could never see on our own. It's as if the cosmos is helping us look deeper, offering us a telescope made of spacetime itself. Let's talk about the color of the universe. A team of astronomers once tried to figure out what color you'd see if you could somehow blend all the light from all the galaxies in the universe together. They sampled the light from hundreds of thousands of galaxies, averaged it all out, and came up with a shade they called cosmic latte, a pale beige like milky coffee, the color of starlight mixed together across billions of light years. It's not as romantic as deep blue or shimmering silver, but there's something charming about it nonetheless. The universe in aggregate is the color of a quiet morning, warm and soft and unassuming. And maybe that's fitting. For all its grandeur and violence and strangeness, the universe, when you step back far enough, is gentle. It's the color of comfort. It's the color of home. Here's something to ease you even further. The speed of light, as fast as it is also a kind of cosmic speed limit that ensures the universe doesn't overwhelm us. If light traveled infinitely fast, we'd see everything in the universe all at once. Every star, every galaxy, every event happening simultaneously. The sky would be unbearably bright, flooded with light from countless sources, and we'd never see the stars as distinct, individual points. But because light takes time to travel, because distance creates delay, we see the universe in layers, in moments, in a slow unfolding of history. The night sky is dark because light has limits, and in that darkness, in those gaps between the stars, there's room for rest, for quiet, for the kind of peaceful contemplation that's carrying you towards sleep right now. The universe is not rushing, and neither should you. Did you know that some moons in our solar system have more water than Earth? Europa, Enceladus, Ganymede. These icy worlds, locked in the outer reaches of the solar system, hold vast oceans beneath their frozen crusts, and those oceans contain more liquid water than all of Earth's oceans combined. It's a strange thought, isn't it? We think of Earth as the water world, the blue planet, the place where water defines the landscape and makes life possible. But out there in the cold and dark, there's even more water waiting, hidden beneath ice, warmed by tidal forces, possibly harboring life we haven't yet discovered. The universe is generous with water. It's generous with the ingredients for life. And even if we never find life on those distant moons, the fact that the conditions might be right is enough to inspire hope. We're not alone in having oceans. We're part of a larger family of watery worlds, scattered across the solar system, each one holding its own quiet mysteries. Let's consider the Helix Nebula, sometimes called the Eye of God, a planetary nebula about 650 light-years away, formed when a sun-like star exhausted its fuel and gently expelled its outer layers into space. The result is a glowing shell of gas, lit from within by the dying star's ultraviolet light, expanding slowly outward, fading as it goes. It looks like an enormous eye staring back at us from the depths of space, serene and haunting and beautiful. And in a way, it's a preview of our own sun's future. Billions of years from now, the sun will do the same thing, swell into a red giant, shed its outer layers, and leave behind a glowing nebula and a white dwarf core. The Earth will be gone by then, either consumed by the expanding sun or left as a charred, lifeless rock. But the sun's atoms will live on, drifting through space, eventually becoming part of new stars, new planets, new worlds. It's not an ending, it's a transformation. And there's a kind of peace in that, the knowledge that nothing is truly lost, that everything just changes form, that the universe recycles itself endlessly, creating and destroying and creating again. Here's one more thought to carry with you into deeper rest. The night sky you see is different from the night sky your ancestors saw. Stars move slowly over thousands of years. The constellations shift. New stars are born, old stars die. If you could somehow travel back in time 100,000 years and look up, the sky would be recognizably similar but subtly different. Some stars brighter, some dimmer, some in slightly different positions. And if you could travel forward 100,000 years, the changes would be even more pronounced. The sky is not frozen. It's evolving just like everything else. And in a strange way, that makes every night unique. The particular arrangement of stars above you right now, the specific photons entering your eyes from distant suns, is a configuration that has never existed before and will never exist again. You are seeing a sky that is yours alone, shared only with the people alive in this moment. And that's a gift. A fleeting, unrepeatable gift. And tonight, as you close your eyes, you can carry that sky with you into your dreams. Let's pause again. Let's just breathe together for a moment. In through your nose, slow and steady, filling your lungs with quiet air. And out through your mouth, releasing whatever tension might still be clinging to your shoulders, your jaw, your thoughts. You've traveled so far tonight, through nebulae and black holes, across oceans hidden beneath ice, out to the edges of the observable universe and back again. And you've done it all from the safety and comfort of your bed. You don't need to go any farther unless you want to. You can stop here. You can let the rest of the facts wash over you like rain, or you can drift off entirely and let them go. Either way, you're exactly where you need to be. Rest now. The universe will wait. Out in the constellation of Orion, there's a star called Betelgeuse, a red supergiant nearing the end of its life. It's one of the brightest stars in the night sky, easy to spot even from light-polluted cities, glowing with a distinct reddish hue. Betelgeuse is enormous. If you placed it at the center of our solar system, its surface would extend past the orbit of Mars. And it's unstable. Astronomers have watched it dim and brighten irregularly, pulsing like a slow, cosmic heartbeat. One day, maybe tomorrow, maybe 100,000 years from now, Betelgeuse will explode in a supernova, briefly outshining the entire galaxy, visible even in daylight from Earth. When it does, it will be spectacular, but it won't hurt us. It's far enough away that we'll just get a light show, a new bright star appearing in the sky for weeks or months before fading away. And then Betelgeuse will be gone, its atoms scattered into space, its light a memory. But for now, it's still there, still shining, still holding on, a dying giant waiting for its final act. Let's talk about the concept of cosmic perspective. The idea that when you zoom out far enough, the things that worry you start to seem smaller. Not unimportant, but smaller. Your unpaid bills, your difficult relationships, the mistakes you made last week. They matter to you, and they're real, but they're also temporary, local, confined to this one tiny planet in this one tiny corner of the universe. And sometimes, just sometimes, it helps to remember that. To look up at the night sky or to think about the vastness of space, and to let that vastness put things in proportion. You are small, yes, but you're also part of something immense. And your problems, as heavy as they feel, are not the whole story. There's more to existence than what's happening in your life right now. And tonight, you can let that more hold you gently while you rest. Did you know that the International Space Station orbits the Earth every 90 minutes? The astronauts aboard see 16 sunrises and 16 sunsets every day. The Terminator line between light and dark sweeping across the planet below them in a constant, mesmerizing dance. They watch storms spiral across oceans, city lights glittering in the darkness, auroras shimmering at the poles. They float in microgravity, looking down at the only home humanity has ever known, and they report feeling that overview effect we talked about earlier, that profound sense of connection and fragility. And while most of us will never experience that view, we can borrow it, imaginatively. We can close our eyes and picture the Earth from above, that blue marble hanging in the void, and we can feel, just for a moment, what it might be like to see it whole, to see how beautiful and how small and how precious it is. And maybe that's enough. Maybe imagination is its own kind of spaceflight. There's a lake on Titan, Saturn's largest moon, and it's not made of water. It's made of liquid methane and ethane. Titan is the only world in the solar system besides Earth with stable bodies of liquid on its surface, and those liquids form lakes and seas and rivers, carving channels through the icy landscape, fed by methane rain that falls from thick, orange skies. It's a hydrological cycle, just like Earth's, but with a completely different chemistry. The temperature on Titan is about -290 degrees Fahrenheit, far too cold for liquid water, but perfect for liquid hydrocarbons. Scientists have even detected waves on Titan's seas, tiny ripples stirred by gentle winds. Imagine standing on the shore of a methane lake, watching waves lap against the icy rocks, the sun, a dim, distant point of light filtering through the smoggy atmosphere. It's an alien world, but it's also strangely familiar, proof that the processes we know from Earth can happen elsewhere, in different forms, under different conditions. The universe is full of echoes, strange mirrors that reflect our world in unexpected ways. Let's drift back to the concept of cosmic recycling. Every atom in your body has a history. The oxygen you breathe was forged in the heart of a massive star billions of years ago, released when that star exploded, and eventually incorporated into the cloud of gas and dust that formed the solar system. The carbon in your skin cycled through plants and animals and the atmosphere before becoming part of you. The iron in your blood was created in a supernova, scattered across the galaxy, and now it's here, flowing through your veins, keeping you alive. You are not separate from the universe. You are the universe rearranged. And when your life ends, your atoms will go on to become other things: soil, water, air, and eventually perhaps other living beings. Nothing is wasted. Nothing is truly lost. Everything just changes form over and over in an endless cycle of transformation. And tonight, as you rest, you can take comfort in that continuity, in the knowledge that you're part of something that has always been and always will be. Here's a final thought for this section. The universe doesn't know you exist. It has no awareness of your hopes or fears, your joys or sorrows. It's not indifferent, it's just unconscious. And yet through you, through the atoms that make up your brain and body, the universe has become aware of itself. You are the way the cosmos knows it exists. You are the mechanism by which hydrogen, forged in the Big Bang and refined in stars, has learned to wonder about its own origins. And that's extraordinary. You are not just in the universe. You are the universe, awake and thinking and feeling. And tonight, as you drift towards sleep, you're giving the universe a chance to rest too. To pause in its endless expansion and simply be, for a little while, at peace. There's a type of galaxy called an elliptical galaxy, and unlike the flat, spiral galaxies we're familiar with, like the Milky Way, elliptical galaxies are shaped like footballs or spheres, with their stars moving in random orbits rather than organized rotating disks. Many elliptical galaxies are old, filled with ancient red and yellow stars, their star-forming days long behind them. They're the retirement homes of the universe, quiet and dim compared to the bright, active spirals. But they're also incredibly massive. Some of the largest galaxies in the universe are ellipticals, containing trillions of stars, dwarfing the Milky Way. And they're often found at the centers of galaxy clusters, having grown fat by consuming smaller galaxies over billions of years. It's a slower, gentler kind of violence. Galaxies merging over millions of years, their stars passing through each other like ghosts, eventually settling into a new, combined structure. And in that long, slow process, there's a kind of inevitability, a patience that mirrors the universe's own rhythm. Everything changes, everything merges, and eventually, everything finds a new equilibrium. Let's talk about the concept of the observable universe. When we say the universe is 13.8 billion years old, we're talking about the time since the Big Bang. But the observable universe, the part we can actually see, is larger than 13.8 billion light years in radius, because the universe has been expanding this whole time. The most distant objects we can see are now about 46 billion light years away, their light stretched and redshifted by the expansion of space. Beyond that distance lies the unobservable universe, regions of space so far away that light from them hasn't had time to reach us yet. And because the universe is expanding, it never will. Those regions are forever beyond our horizon, forever unknowable. And yet they're still out there, still real, still full of galaxies and stars and maybe even civilizations looking up at their own skies and wondering if they're alone. There's something both humbling and freeing about that. The knowledge that the universe is bigger than we can ever know, that there are mysteries we'll never solve, and that's okay. We have enough wonders right here within reach to last a lifetime. Did you know that some asteroids have their own moons? These tiny worlds just a few miles across hold even tinier companions in orbit around them, bound together by the faint whisper of gravity. It seems almost absurd, a rock orbiting a rock, both of them tumbling through the vastness of space, but it's real. The universe doesn't care about scale. Gravity works the same whether you're a planet or a pebble. And there's something charming about these miniature systems, these little families of stone spinning through the dark, never to be visited, never to be named, just existing because the laws of physics say they can. The universe is full of small wonders that no one will ever see. And maybe that's part of its beauty, the fact that it doesn't create wonders for an audience. It just creates them and they exist, and that's enough. Here's something soothing. The light from the stars is always reaching Earth, even during the day when you can't see them. The sun is so bright that it drowns out the starlight, but the stars are still there, still shining, still sending their photons across the void. And at night, when the sun dips below the horizon, those stars become visible again, as if they've been waiting patiently all day for their turn to shine. It's a reminder that some things are always present, even when you can't see them. Hope, beauty, connection. They don't disappear just because your attention is elsewhere. They're still there, waiting for you to notice again. And tonight, the stars are out, whether you see them or not, glowing softly in the dark, a quiet reassurance that the universe is still here, still turning, still filled with light. Let's consider the rings of Uranus. Yes, Uranus has rings, though they're not as famous or as spectacular as Saturn's. Uranus's rings are dark and narrow, made of small, rocky particles rather than bright ice, and they orbit the planet at a steep angle because Uranus itself is tilted on its side. The planet rolls through space like a barrel, its poles pointing alternately toward and away from the sun as it orbits. This extreme tilt, probably caused by a massive collision early in the solar system's history, gives Uranus the strangest seasons in the solar system. Each pole experiences 42 years of continuous sunlight, followed by 42 years of continuous darkness. Imagine living on a world where summer lasts for decades, and then winter does the same. It's disorienting just to think about. But it's also a reminder that planets like people can be knocked off balance and still keep going, still hold together, still maintain their own strange kind of beauty. And here's one more thought to ease you into the final stretch of this journey. The universe is not hostile. It's not friendly either. It's indifferent, which sounds bleak but is actually freeing. The universe doesn't care if you succeed or fail, if you're happy or sad, if you figure everything out or spend your whole life confused. And because it doesn't care, you're free to define your own meaning, to create your own purpose, to decide for yourself what matters. You don't need the universe's permission to be happy. You don't need its approval to rest. Tonight, as you lie here, you can let go of the weight of cosmic significance and just be a person, in a bed, in a room, on a planet, breathing and resting and dreaming. And that's enough. That's more than enough. You are enough. And so we've come to the end of our journey tonight, though in truth, the universe's journey is far from over. Out there, beyond your window, beyond the atmosphere, beyond the moon and the planets and the distant stars, the cosmos continues its slow, patient work. Stars burning, galaxies turning, light traveling across unimaginable distances. All of it moving according to laws that are both beautiful and indifferent. And you, right here, right now, are part of that vast, unfolding story. You always have been. I hope that tonight's facts have brought you a little peace, a little wonder, maybe even a little comfort. It's easy to feel small when you think about the universe, and you are small in the grand scheme of things. We all are. But being small doesn't mean being insignificant. Every atom in your body is billions of years old. You are made of stars. You are the universe looking back at itself, and that makes you part of the most extraordinary phenomenon we know: consciousness, awareness, the ability to ponder and wonder and dream. You are not separate from the cosmos. You are woven into it, intimately and irrevocably. And maybe that's the most relaxing thing of all, the knowledge that you belong. You didn't ask to be born, and you don't have to justify your existence. You're here because the universe made you, because billions of years of cosmic evolution led to this moment, to you, lying in bed, listening to facts about space, breathing in and out, alive and aware. And for tonight, that's all you need to be. Just here, just breathing, just resting. If you're still awake, that's okay. Sleep will come when it's ready. And if you've already drifted off, then I hope these words are weaving themselves into your dreams, turning into starscapes and nebulae, distant worlds and gentle suns. Either way, you're exactly where you need to be. Before I let you go, I want to thank you for being here. Whether this is your first time listening or you've been here before, thank you for choosing to spend this time with me, with these facts, with this quiet space we've created together. If you enjoyed tonight's journey, consider subscribing to the channel. There are more cosmic adventures waiting for you whenever you need them. And if you'd like to help others find this peaceful corner of the internet, a like and a comment letting me know how you're feeling would mean the world. But no pressure. Your only job right now is to rest. The universe has been here for 13.8 billion years, and it will be here long after you wake. The stars will still be shining. The galaxies will still be turning, and the great cosmic dance will continue, patient and eternal. And you'll be here too, refreshed and ready for a new day, carrying with you the quiet knowledge that you're part of something vast and beautiful and strange. So close your eyes now if you haven't already. Let your breathing slow. Let your thoughts drift like clouds across a summer sky. The universe is holding you gently in the palm of its gravity on this small blue planet spinning through the dark. You are safe. You are part of the whole, and tonight you can rest. Good night, sleep well, and may your dreams be filled with stars.